Cool. Thank you all so much for coming. My name is Stephen Basgall. I'm a senior DevOps engineer at GoGoAir. We've been using Spinnaker since it was open sourced. So that's when I started this journey. We kind of all learned AWS at the same time. So I'm sure there's a lot of people here who are in a similar situation now. Pete mentioned when the conference opened about community and what we can give to each other and all that. So I created my Twitter account in 2009, and I've actually never tweeted. But this morning I went and reset the password and logged in because the Spinnaker community has helped me out so much. I want to be available to help out other people. So if you want to tell me how I did or anything at all afterwards, I guess I don't know how it works. I guess you can send it to that, and I'll see it somehow. So please, I'd love to hear from people. We're going to talk today about integrating Chaos Monkey in Spinnaker. This was upgraded from an office hours talk and a lightning talk to this full session because of the interest. So thank you. It's great to see the conference organizers continuously adapting, like what rooms based on demand things are in, so the most people can have the opportunity to see the sessions they want. So thanks to the organizers for that too. You may see in the description for this, it mentions Docker Compose. That was kind of something specifically for office hours. I'm not going to talk about it too much. We will discuss Docker a little bit, but I'm happy to explain that afterwards if anyone has any questions. So this is basically what we're going to cover today, a really quick practical overview of chaos engineering, the requirements to run Chaos Monkey, how to configure Chaos Monkey, what happens during the termination cycle when these chaos events are scheduled, some ways to get started with observation and safety, and then some alternate configurations other than what's suggested by the Chaos Monkey team as far as deployment for Chaos Monkey. So a quick raise of hands. It's a lot more popular now. Who's heard the term chaos engineering? Who's familiar with that? So it's not everyone. It's something that's been going on for a long time. It's not a new thing. It's basically failure analysis. In this cloud world, it's helpful to determine that the state of a lot of the services you have deployed if you have complex services. So if you've ever been to IKEA, sometimes they have like a demonstration of how they stress test their furniture. So it's the same kind of idea. They put it through cycles, they put it through things that they expect to break it, and they see how strong it is. Automobile crash tests is something everyone's familiar with. It's the same kind of idea too. They take that car and terminate it and record what happens, and lots of instrumentation in there. So they don't do that in production, but they're required to do it even to sell cars. That's how important it is. So there's a few basic types of chaos exercises that can be done in a web services environment. You have things like system loss, which would just be a system disappearing, kernel panic, something like that. Network partition, maybe part of your network topology is unavailable and you want to make sure your applications can still be resilient. Things like disk failure, extreme network or I/O latency. These are all exercises that we can run applications through to see what happens. So you have a lot of observation opportunities when you run these exercises. You can see the behavior of other systems other than the one you're terminating and see if they had any adverse reaction to that termination event. You can test your automatic service recovery. There's the potential to discover unknown or undocumented dependencies that will arise when services go down. You have a chance to observe cascading failures and make sure that one service going down doesn't trigger everyone else's health check to also go down. And then failure signatures, which is something that's really important for like a NOC or SRE or operations team, just to know what the log messages are. For a NOC, what their environment looks like during an outage is visually to help them classify what's going on and respond faster. And then you can tune alerting too. So you know the exact time. There's a record of the exact time this chaos termination was performed. And you can see the delay between your alert and how long it took and work on the performance of that if you need to. Some e-commerce companies, if you're selling $1 million a minute and you can shave a minute off that response time, it could be worth trying to drive that alerting as tightly as possible. So you can begin by system loss is a great place to start because it kind of crudely covers all those other failure types. And you can start as simply as manually terminating an instance, right? Like you just go in and into your dev environment and you'll terminate an instance and then observe what happens. And that's kind of like the first step. That's the most primitive form of doing it. The next step after that is where Chaos Monkey can be really helpful, and it's very easy to set up and gives you quick value in this area. So this is a diagram of hypothetical microservices some company might have. This isn't my company, just to be clear. Say you're sitting at your desk one day and the CTO comes up to you and shows you this diagram, and they ask you to identify the risk of losing each service. You can see there's a lot of services there, right? Let's say the applications are written by a dozen teams. Some of them are written by contractors 4 years ago. It could be a total of millions of lines of code. How are you going to do it? Are you going to tell the CTO this is impossible? Are you going to tell the CTO it'll take 12 months or 24 months? Are you going to say you need a resource on each team to answer code level questions about everything? Those are some options. I think that with the discipline of chaos exercises, you can get that information without having to deal with any of that stuff. It will allow you to identify where defensive design needs to be added if one of these services would go down. Things like caching, retries, testing shields up, and disabling non-essential features as a coping strategy to whatever turbulence they're experiencing in their environment. Once you start doing that, you can iterate and tune that defensive design, looking at things like timeouts, retry logic, fallback settings, to try to remedy any service outage that these terminations cause. So this is where Chaos Monkey comes in. It provides a way to automate system loss in a low-friction, self-service way. Netflix released Chaos Monkey 1 in 2011. It supported more failure types than just system loss or system termination. And it was written in Java and part of a larger suite called the Simian Army. It included things like Chaos Gorilla that would even simulate the loss of an entire availability zone. So not too long ago, Chaos Monkey 2 was rewritten in Go from a Spinnaker perspective. Only instance termination is supported as far as the failure types. But Spinnaker integration was added, and it supports a self-service model. So I think that's more valuable than having 20 different chaos exercises to pick from and trying to come up with your own way to decide who participates in that. So like I mentioned before, that system loss event really crudely replicates those other events too. The requirements for Chaos Monkey are the Go binary installed on an EC2 instance, a MySQL database that's accessible to the instance where the termination scheduling and termination history are stored, And then the Chaos Monkey instance needs network access to Gate's API. So all the actions it does go through Gate. One thing to note here is that if you're thinking of taking Chaos Monkey and adding other failure types to it, I know a lot of the other patterns out there will use SSH or some kind of network connectivity to trigger that event. You may not have network connectivity to your actual running applications from the Chaos Monkey instance itself if it's in some other account. So it's going to access Gate and perform those operations like that. So it's just something to consider if you're seeing this and interested in more than just termination events as a chaos exercise. The configuration is really simple. You can pick its state, which is leashed or unleashed. Leashed is really helpful for debugging before you go live to make sure that Chaos Monkey is behaving like you think. It's basically a dry run mode. It will simulate what it's done and tell you what it would have done, but not actually terminate the instances. So unleashed is the configuration state that will let Chaos Monkey do its full terminations, and that's where you need to do that to get it to work. You'll need to configure your accounts too. These are just the Spinnaker names for your accounts. So in my case, it's things like dev, stage, prod, like that. And then you'll need your Gate URL, an authentication type for Gate. Probably different people authenticate with Gate in different ways. It supports X509. It supports, as far as I know, all of the authorization types that Gate has. And then you'll need the SQL database name or endpoint and the credentials for that. So you don't need a whole lot to get started. These are really simple things. The Chaos Monkey instance itself can run on a T2 small, T2 micro. It's not doing a whole lot. So it doesn't need a lot of power behind it. So the infrastructure is very inexpensive. Once you fill out the configuration file and you're testing the Chaos Monkey binary from the command line, Chaos Monkey config is going to let you know that Chaos Monkey is reading that configuration file and understanding what's in it. So these are the same values that we just talked about in the configuration file, and this Chaos Monkey will print this when you run the config command. If you run the config command with an application name as an argument, it'll show you the application configuration object for Chaos Monkey. And we'll see in a second just how that's created. So once Chaos Monkey's user interface is enabled in Dex settings.js, any application can opt in from the application's configuration page. It may even just be uncommenting a line in that file. I haven't done it lately, and we treat that file in a CI/CD process. So I'm not positive what that looks like, but it's a one-line change to a JavaScript settings file in Deck. You can see this is what developers will see, or whoever is opting in applications will see when they go to their Chaos Monkey configuration. And they're going to be able to set criteria in here, whether they're opted in, what environments that they want to participate in, and it'll enumerate all the environments. Even if you don't have them configured in Chaos Monkey, it will show them here, but there's no chance terminations will ever occur on the ones that aren't in the configuration file. Other things like the account name, region, stack, if you want a specific cluster, the detail, and then the minimum time between termination and days. So you may not want it getting terminated every day or every other day or even every week. And you can supply that information, and Chaos Monkey will use it when it's making a termination decision. So how the termination cycle works is every morning, Chaos Monkey will run the schedule command. The default installation has cron orchestrate that. So every morning before your termination window comes, it will schedule the terminations for that day. What that schedule command does is it queries the Gate API to list all the applications. It determines the ones that have Chaos Monkey enabled. In addition, on those, it will go in and retrieve some metadata about it. Just so happens to be the exact same thing that you supplied in that UI. So account, cluster, it gets all of that and incorporates it into its decision. Once a decision has been made and the scheduling is complete, it will make a decision on each one, and if they qualify for Chaos, it will write them into a new cron file. So Chaos Monkey is going to use your system's cron capabilities to actually drive these terminations in its default configuration. You can see here what the cron file looks like. It's picking some times at random. At random. And to do the terminations, it's calling a shell script, and then it's providing some extra details, which is name of application, environment, cluster, region. And those get passed to Chaos Monkey terminate shell script, which then just runs the binary, supplies that information, and saves a log. So when that's run, for each of these times, it's going to run, and it's going to write to that log, terminate the instance, write to your database, and move on and just wait for the next termination order to come. So at this point, the default configurations of Chaos Monkey are just about completely explored. What's going to happen is it will be running every day, Monday through Friday in the default configuration, running that schedule command, preparing the terminations for the day, and then as the day goes along, it's going to terminate instances that are on that list. That's great, but what you don't have is a way to notify that it's happened, or kind of what's going on in the background. So luckily, they provide a great way to take care of that in a way that's appropriate for your business and organization. There is a tracker interface that's unimplemented, and instead of relying on email or guessing when terminations occur, every termination event will call this tracker interface. So I made one. I left out the boring parts. I mean, it's all boring, I suppose. The extra boring parts aren't there. And what this does is every time there's a termination, it's just going to post a message in Slack. The termination object includes all of that metadata that we've talked about previously, and you can arrange that in the Slack message in a way that's meaningful for your company. This was the first Go I ever wrote was this interface. So it's very approachable. If anyone's ever struggled or been intimidated looking at the Spinnaker code base, this is much more bite-sized and accessible and easy to understand. Using that tracker interface, we talked about announcing to teams, and that would be, a Slack chat message where some team is notified that a termination event occurred. That could be the development team, it could be an operations team, it could be the CEO, it could be anyone you want in the company. And that's a great way to get started. It's a really low friction way to get started, but ultimately, the usefulness of it, as you scale this practice in your organization, it's going to get a little much and hard to make sure that you're doing all your observations and checking in on everything. So the next step up from that, to me, would be Grafana, for example, allows you to pass the start time of the graph you're looking at as an HTTP parameter. You know that start time as part of the termination object. So what that Slack posting can do is actually create a link directly to your dashboard at the exact moment that this happened. The end time is much harder to establish, But the beginning time is the most important piece as far as observing this event. The next step up from there would be to use this tracker to create an annotation. If you have a company-wide metric system, time series database information that's shown, you can create an annotation for the event, give it an ID, and share it with every team and let them overlay that annotation onto their own application graphs. And then finally, I think if you've gotten to the point where you have many people wanting to do many different things and kick off new workflows based on these termination events, the pub/sub method is probably good. If you have a more advanced networking capability at your company and you can have a cluster that's running 1 or 2%, you can have that as your target in production or in an SLA stage environment to do your observations. It's not going to be one-to-one, but it will give you a chance to do it potentially. You can be selective about which applications qualify. Establish a criteria for candidates for this, and it's going to be different for every application and in every company. But a good way to start is in the development and non-prod environments, seeing success there. You probably want to see success there before you start trying it in stage, for example. Using safe time windows is also an option. Maybe for whatever reason, this is becoming more and more rare, right, as the years goes on. But you have a 1 hour window that doesn't violate your SLA, where people are still using your service, but it's kind of no guarantee at that time. Maybe you have that once a month. You can restrict it to that time window. Obviously, if you have a lot of services and you restrict them to that time window and they all get terminated, probably everything will be terminated at the same time, if it's like an hour. But if there's something, if you have a hypothesis you want to figure out or observe behavior of something, it's one option. And the final thing, kind of the most interesting thing to me, and this could be the subject of a whole other talk, is using an outage beacon to ensure safety in production. In theory, if your stage environment is exactly the same as your production environment, you may not need, you may feel that it's good enough. And that can be true, but often in the data plane, network topology, request volume and characterization, there's going to still be differences between stage and production unless you work really hard and invest a lot into making that stage environment identical. So Chaos Monkey has another unimplemented interface to assess the status of an outage beacon before it performs termination. An outage beacon is just an idea that something somewhere can tell you if you're having an outage or not. A simple way to do that is just to simulate an HTTP health check and just have a service out there that when it returns 200 OK, that means no outage. Anything else is an outage. So Chaos Monkey can reach out to this beacon at termination time and cancel, skip the termination if that outage beacon is lit. So if you're experiencing some other outage or some other diminished capacity, if this beacon is lit, you know that Chaos Monkey will not be active as long as it's lit. It has other uses as well. I'm not going to get into too much because it's outside of the scope of this presentation, but you can use it to assume a defensive posture in your applications during outages, coordinate outage responses in a programmatic way. There's a lot that you can do with these outage beacons. Use them to drive your status page, trigger them from a status page. So once you have it, assuming Chaos Monkey is the only thing using it, you have a lot of opportunity to break this beacon as you're making it. So once everything is kind of watching it, if that turns false, if that indicates an outage, it's probably going to be a long night. So I think the steps of maturity for working with this beacon is it could be even manually activated from incident responders. You can trigger it if you have a system like Everbridge or an incident response system. A lot of those are able to fire off webhooks as they create incidents or declare outages. So you can trigger the beacon off of that. And they have close times too, so you can unlight it. Finally, it can be triggered automatically. If you have advanced incident detection systems and you have a lot of confidence in them, you can wire them up to an Outage Beacon. I'm guessing if you have these systems already, you probably already have an Outage Beacon, but if not, definitely add one. So we talked about the EC2 deployment, what's needed for that. There's some alternate designs too. Chaos Monkey basically sits there all day and just does a few things. So almost all the time it's not running or doing anything, only when these processes are invoked by cron to go and do this or that. You may want to run it in ways where that EC2 isn't just going to waste all day. So the server requirements are so low, this isn't a good money-saving technique. I think you could probably run this for 20 bucks a month on a server. It's more for if you're an engineer and you can't help yourself and the inefficiency is just driving you crazy. There's some paths you can explore to run it in a different design. The concepts used to do this conversion from the kind of provided EC2 installation instructions to serverless or containerized deployments are going to be useful. And you may be able to apply those to your business applications as well if they're going through the same transformation. So this isn't required, but you can get a lot out of this. Basically, for containers, you just need a container that has the entry point of the binary, and it'll let you execute all the different commands. A container schedule is also very helpful because you need to replace cron with a container schedule, basically. So instead of running that bash script that runs the Chaos Monkey terminate, you can run a Docker container with the Chaos Monkey binary on it, and through the entry point, pass in terminate and all the conditions there. All of a sudden, that EC2 instance is not as required. To do this, we have to bypass cron. That cron installation is very stateful. It's only needed for a day, so you don't need to back it up or anything like that. But in a containerized and serverless world, cron's not adequate to fire these events. So you can read the database directly. It shouldn't be too complicated. Read the database directly and then use that to put things in your container schedule that will do the termination events instead of reading it from the cron file. As far as Lambda, I've gone further down the container route than I have with the serverless route, but they're similar. I've taken command line utilities from other ones and been able to turn them into serverless functions to replace periodic execution of running them in Jenkins every 4 hours or something like that. You can just run it serverless, and it's a lot easier to manage. There's a lot of benefits to that. So I suspect it's possible with Chaos Monkey as well. I'm looking forward, being new to Golang, I'm looking forward to playing around with that and seeing what I can do. So there's a few resources I'd like to point out. Last year at reInvent, Norah Jones from Netflix gave a great keynote about why you should use Chaos Monkey. I tried not to overlap that because I'm not going to be able to say it as good as her, and I'm kind of telling you how to use it. But I'd highly suggest you watch that, especially if you're in a position where you have to sell this to your company or your leadership. It's going to be very beneficial to watch that. There's a free ebook published by the Chaos Engineering team at Netflix that isn't super focused on Chaos Monkey, but Chaos Engineering in general. Definitely check that out. And the documentation is actually quite good for Chaos Monkey, so that's a great reference too. So this is just the beginning of Spinnaker's chaos story. Andy mentioned in the keynote on Monday that Gremlin.io is interested in working with Spinnaker, and they seem to me to be one of the leading providers of chaos as a service. Also, I'd invite you to think for a moment about automated canary analysis and how that overlaps with chaos observation. They're not exactly the same, but they have a lot of the same steps and a lot of the same requirements, to do automated chaos observation as automated canary deployments.